Okay, so this is video for the task B of the lab 6. So in this task, what you need to do is that you just need to download these two files, lab6 taskb.ini and adc.s, and put them in a new Arduino sketch named lab6 taskb. Then you need to complete the missing parts in adc.s files, and those missing parts are indicated by to dos from 1 to 9. So after completing, you need to show the TA that your code is working and you have implemented the pseudocode which I described in the video of the task A, or actually this pseudocode, right? So now let me show you the skeleton for the task B. So the .ini file is pretty simple. It's just simply calling the function read port or read potentiometer. And then here, what you need to do is like, I have already described for you all these equate directives so that your code becomes more readable. So what you need to do is like, this was the function for turning on the LEDs or switching on the LEDs, test LEDs. But this time we are calling the function read port, so our control starts from here. So first to do is that you need to configure the port B and D as output ports. Then you need to disable the digital input buffers on ADC pins. The third to do is that you need to write ADMUX such that you select ADC0 as analog input, AVCC as VREF, and make the 10-bit output write justified. Then next to do is to write the ADCSRA register to enable ADC or analog to digital conversion module itself, but not start the conversion. You need to set the prescaler to 1/128. So you need to write the proper values in the prescaler bit fields of the ADCSRA register. And you also need to use the polling mode, which means that you need to set ADIE bit in the ADCSR register to 0. Note that do not set the ADSC bit of the ADCSRA register at this point. So don't set the ADCS bit to 1 at this point. And next to do, you need to start the conversion, and for that you need to set the ADCS bit of ADCSR register to 1. And for that you need to use OR operation to set only the ADSC bit in the ADCSRA register, and all other bits should be untouched. So they should retain their values, all other bits. Only the ADSC bit, which is bit number 6, should be set equal to 1. Then next to do is to wait until the conversion is complete. And how you know that conversion is complete? You continuously monitor the value of the ADIF bit, right, in the ADCSRA register. For that, what you can do is that you can simply load the value of ADCSRA register, let's say into R16, and then you perform the OR operation on the register R16 such that you get the not OR operation or OR operation actually AND operation. So you can use AND operation. So you can use AND operation to mask all other bits, and but the ADIF bit, which is bit number 4, uh, and get the result of AND operation in R16. So if the result of AND operation is all zeros, which means that your ADIF bit is not set yet, then you need to go back to the loop. So you need to keep waiting, right? So wait until conversion is complete. So how you can do for that, you can use AND I operation and branch equal instruction, right? This will be a little bit tricky. You need to think about it. I don't want to give away the solution here, but I have already given you the hint how to do that, right? So next to do is to after you get out of the loop where you are monitoring that whether the ADIF bit is set or not. So once it is set, you get out of the loop and then you need to read the 10-bit digital output of analog to digital conversion. So you must first read out of ADCL, which is the lower register, and send it to the port D, and then you read out the ADCH value and send it to the port B, right? And then the next to do is to reset the ADIF to 0 to start the next conversion. Remember, when a conversion is completed, the ADIF bit in the ADCSRA register is set to 1 automatically, which you are monitoring, right? And you are waiting until it becomes 1. So after reading the values from ADCL and ADCH register, you need to set that bit again to 0 so that the next conversion can be started. However, again, it is a bit tricky. How you set the value of ADIF bit to 0, you actually write 1 to it. So when you write 1 to it, the hardware will automatically set up its value equal to 0. So to set the bit to 0, the microcontroller wants you to write 1 to the bit ADIF of the ADCSR register. Yes, it is not a typo. You need to write 1 to ADIF bit. Okay. And after writing 1, again, for writing 1, what you can do is you need to do the logical operation, right? Load the value of ADCSRA register, for example, in R16, and then keep all other bits untouched, only write 1 on the bit position of ADIF, which is bit number 4. And then after writing it, you need to simply jump back to do 5 so that you are in an infinite loop. And that is what you need to do in this task. So once you are able to do that, you will see that as you rotate the knob on your potentiometer, the value on the LEDs will change. So now let me stop sharing the screen so that I can open the solution and download or upload on my microcontroller and show you it in working condition. Okay. So So here I have uploaded the code on my microcontroller. It's a little bit difficult to show you, but here is my all the hardware and the code is already running. So where is my yeah, here is the potentiometer. Here is the potentiometer if you can see, right? So it is like on maximum size, so maximum resistance. So maximum resistance means the 0 voltage, so all the LEDs are turned off. Now if I start it rotating, so which mean I start increasing the input voltage, so you can see the LEDs are, so LED on this side, this is least significant bit, and this one is on this side is the most significant bit. So as I will keep increasing the voltage by rotating the knob, the LEDs on the most significant bit sides, they will also start switching on. So for example, here you can see that the most significant bits are also getting switched on. So here now all the LEDs are on. So which is like the LEDs are displaying the maximum voltage, right? And if I like turn it back, so now I am reducing the voltage, and as I'm reducing the voltage, you will see that the bits LEDs on the most significant bit side, they will start one by one switching off as I keep reducing the voltage. So here they are now, I'm back to zero again. Okay. So this is what you are supposed to have when you successfully complete the task B. So after completing the task B, show your show the values to the TAs that the values on your LEDs are changing as well. Okay. So that is all what you are supposed to do, and then you need to submit the files to the to online canvas submission, and to get your scores. So that's it, and good luck for the lab.